So just to kick off this meeting, actually, one question from previous talk. I don't know, I've been developing in Java for maybe 10 years ago, but there is a kind of read-only mutable enumeration in .NET, and it's called enumerable. So you can just enumerate the things what's inside, you can't remove. If you would like to manipulate that collection, you have to either custom or create a new collection based on that. So there is read-only collections.
But there is no count.
Well, actually, it's not.
There is no. There is basically you are iterating through the count through the collection. Yes.
You have iterable in Java as well. You have read-only collection in the .NET that implements collection for some reason, which has apps and remove, which don't work. So the example was.
Also, yeah, there was a question about functional programming and solids. Actually, solids really great applies to the functional programming as well. For instance, one of the dependency injection pattern called the method injection, which is basically could be treated as single responsibility principle. If you have like a zillion arguments for the method, it's kind of violating that particular principle. Most probably that method knows too much in order to make that work. So either you do some refactoring on the method arguments or you do some other stuff. And basically, those solid principles really apply to the functional programming as well. That's not a big deal as well. Anyway, so today I wanted to talk about dependency injection. The title contains .NET, but it's not only .NET. The examples will be .NET as I'm a .NET developer, but it applies based on all the object-oriented programming languages and the functional programming languages as well. So my name is Valdis Iļjučonoks, and I'm officially I'm technical fellow, whatever it means. Basically, I'm doing all the stuff. Most known, it's kind of a full stack developer plus architect plus program manager plus program manager, all those roles. Basically, making things happen in the Norwegian-based company called Locator. So, what do you think why we need to talk about dependency injection topic here? What is the main reason why we should care about this one?
Sounds fancy.
Sounds fancy. Okay, to warm up the audience, I actually have a giveaway book for the best answer. It's dependency injection. So, what do you think? Why are we talking about this topic? What is the main reason for dependency injection?
Single responsibility.
That's one of the principles. Okay. Loose coupling. Again. Yes.
Testing.
Testing.
Make life simple.
Horizon just to survive.
I would actually vote for that answer.
Yeah.
Why? Because when the code is written, it becomes legacy code, right? Immediately after the code is written. So in order to kind of ease our job as a maintainer or other guys who will be kind of working with that legacy code, it's actually really kind of, we have to think about that. We have to think, we have to create the loosely coupled code, we have to make a maintainable code, we have to make testable code. All that principles actually is doing by the dependency injection. And today actually we quickly go through those topics as actually there's a lot of talk underneath, but I'll just skip some of the parts to kind of squeeze in the time frame. So we'll start with the definition. What do you think, what is the dependency? Should I give another book? So dependency, sometimes in the literature, dependency seems like it's some other service or some other service provider or component that you need to take into your component in order to do your work. It's not always true. Dependency sometimes can be also a string or can be some structure or something like that. But actually, that's something, some piece of code or data that you need in order to do your job as a component developer. So dependency injection is everything about injecting that dependency through the various patterns, of course. So sometimes dependency injection actually is named under the object composition or inversion of control. And inversion of control actually is more known in the audience and the industry. So that the keyword here is that what means the inversion of control and what kind of control we are talking about here. The main kind of key takeaway about the dependency injection here is that you as a component developer, you actually don't care how that dependency was born. Will that dependency survive after I will do my job and I will give it back to the caller? So basically you don't care. You make this component, you ask or basically you demand for the dependency if you need to do your job, and then you are letting it go. And that's kind of the main reason of inversion of control. You don't care. You just demand, I need this one, you have to supply, I don't want through one of the patterns. I'm just doing my job and here we go. Just do whatever you need with that dependency. So actually dependency is just a set of principles and patterns to enable loose coupling. So that's not particularly for the specific framework or specific language, it's actually principles and patterns how we are maintaining and how we are developing our code. And it nicely plays together with the solid principles. And through the samples I'll show how various principles apply in the dependency injection as well. So for the patterns, the first pattern is, I would say, the most used, the most mainstream. And I also hear the question about if you have really big dependency constructor injections, you have a really large object graph, that's okay. If you need that dependency, you just have to demand it. If it's like a zillions of arguments in a constructor, there is a way how you can refactor that in order to kind of lose the count of the arguments. But if you need that dependency, you have to demand it. Other way around, there's no other way around. So the constructor injection is really simple. You just create a constructor for your component, and you're just demanding those dependencies in a constructor. Either those are other dependencies, usually those should be some kind of interfaces or some abstractions. There is something that needs to be added to my component in order for me to do my job. And the thing about constructor injection is that once that dependency is given to you, it becomes invariant. It doesn't change during the object lifetime. So usually in the .NET it's declared as a read-only field or private setter with the auto properties. Familiar with the .NET framework. So there's something that you as a consumer of my component, you gave me the dependency, and during the component lifetime it doesn't change. Because there's a different patterns in different cases when that dependency might change, but I will show you the next pattern actually for that one. So that's called property injection. In a property injection, the difference between the constructor injection and property injection is so that constructor dependency injection requires that I just have to have the dependency. There is no other way around. However, the property injection tells you, for me as an API consumer, is so that, it sounds like the dependency is kind of optional. It most probably has its own default implementation under the hood, but if I want to extend the component, I can supply something through that property. So I can override some things, or maybe I can try to set it to null and see how the application blows up, I don't know. But it's optional, it's not demanding. And the key factor here is that dependency is optional. It has its own default, so-called local default. If you will not give me, okay, that's fine. I have my own implementation of that thing. If you would like to, you can give it through the property. And the key factor here is that as you can supply different dependencies through either constructor injection or property injection, here comes this list of substitution principle. That me as a component actually demanding, give me that abstraction, and I don't care, is that abstraction what I'm supposed to work with, or maybe some of the methods or properties will not be implemented and you will throw me an exception. So that's not a good contract between my component and your consumer. So we have to be following this list of substitution principle. That if you give me the dependency, if it's implementing some abstraction, I assume that the dependency will be working correctly as defined by the function. So that's a list of substitution principle in action here. The other case, the method injection, is something that you're actually standing on the other side of the fence. Actually, you do have a dependency already somehow, and you have to give the dependency to a particular component through the method injection. So usually It applies in the cases when you have a component and the component method invocation depends on some sort of context. This is a message that you're formatting, or this is a current user you're applying to some behavior, whatever. So it's done through the method injection. And the last one is, it's a really funny name, but it's called ambient context. And ambient context might not be kind of really formalized in the literature, but basically it means that somewhere there is a cross-cutting concern. And that cross-cutting concern should be accessible for every layer, every slice, whatever you organize your architecture, but that's something that I can always go to and ask. And the most obvious example of the ambient context in the .NET framework is spread current culture. This is ambient context. You can ask, you can get, you can set everywhere. So this is done through the static property, and it's an application of the ambient context. So the interesting question is, if I do have my component, I need to create my component with dependency injection aware understanding and design, which should I use and when should I use? So there is actually a really interesting cheat sheet that you can read, or actually I can get you through. So for instance, you have a dependency in some sort of way you need, or you have that dependency. So if you have a dependency, so then you go for the method injection. So I have a dependency, I'm calling that particular component, I'm just giving that dependency to the method injection. If you need a dependency, then it's kind of your demanding dependency through one of the patterns. And then the next question is actually what kind of dependency it is. Is it a cross-cutting dependency, or it's not a cross-cutting dependency? If it's a cross-cutting, then the next question arises. Do you need an answer from that dependency? Let's say, I don't know, for instance, thread current culture. You need the answer for that culture. You need to understand how should I format my strings or decimals or whatever. So if you need the answer, you go straight here down. If you don't need the answer, there's actually a really interesting pattern called interception. So we'll take a look at that one as well on samples. If you need the answer, so they are not void, you are returning something. So then the question is, do you have a local default for that? So do you need it somehow obtained, or you actually have your own implementation in mind? If you do have, then you go for the ambient context. So basically you're supplying cross-cutting concern, need the answer, have local default, you go for the ambient context. If you don't have local default, it means that I have no idea how to get the dependency. It's a cross-cutting concern, I need the answer, I don't know how to get it, you actually go to Constructor Injection. You just demand it. As a component, I don't care where you get it. And I will show you how the composition happens, but basically from the component perspective, I don't care. You have to supply it to the constructor. So roll back into the original question about cross-cutting concern. If it's not cross-cutting concern, then the next question is similar to this one applies. Do you have a local default for that? So it means that, okay, you can create my component instance, and I do have a property injection applied for some of the dependencies. It has its own default, so you can just new it up and use my component. You don't have to supply the dependency. Then you go for the property injection. Again, if you don't have a cross-cutting concern, you need a dependency, you don't have a local default, again, you just demand it through the constructor injection. That's it for patterns on the dependency injection. And it seems like the constructor injection at the very bottom is not very important and the least thing to choose from. Actually, in the majority of cases, the answer leads to straight to the constructor injection. That's the first pattern that you choose, and then you see, okay, I do have a local default, I don't need to pollute my API constructors and etc. I'm just going either for the property injection or ambient context, or maybe I can do that through the interception. Any questions so far? Yes?
Isn't it true that ambient context actually is anti-pattern because you have to always reference some static field that can't be overridden?
There are two options, opinions about this. One group of people think that this is not anti-pattern, and other people think that it is anti-pattern. So actually it depends on how you apply it. If you are a cross-cutting concern, if you need the answer and you have a local default, you actually go through the ambient context. And actually, in this particular book, the author of the Dependency Injection.net book, initially he actually didn't want to include this pattern because he really thinks that it is anti-pattern. But there are cases that you just have to go with that anti-pattern and basically survive, wash hands after the code written, but there is applications that you actually go for the ambient context. There's no other way around. And of course, .NET Framework, sometimes it's not the use time for you. It just happens. They are also humans, right? Writing the software. So, yeah, it depends. All right, actually, more interesting part is about anti-patterns, how to recognize them, and actually what to do with them. The first one is so-called control freak. Control freak, actually, I do have a sample of that. Control freak is, let's say, in this particular, can you read? Or should I increase? So for instance, we have some silly service called chat service, which means two parties, they are talking with each other. In this particular case, we have one male called John, which plays a husband role, and another living being is female, named Mary. It would be pretty nice if you don't have a wife, you just meet up. But anyway, you just have a chat service, and basically what's happening behind the chat service is in the constructor, it's demanding party 1 and party 2. That's a dependency of the constructor. What's happening inside, for instance, in the constructor of that particular service, is so that, for instance, I'm receiving these parties, I'm storing them, I'm guarding against the invariants, and I'm not allowing them to change later on. We're storing in read-only fields. But let's say later on, I can actually go to the configuration file, read it up, and see what kind of chat channel should that particular application use. So assuming that I do have a configuration file where I can just type either I would like it using a console channel to output everything to the console, or in that case, if I just nulling it up, then I just forward everything to them. So this actually is control freak. It means that this particular component is actually controlling everything what happens inside. And the console chat channel and dev null chat channel, or actually abstraction called iChat channel, is dependency for this particular component. And everything happens inside. It's a control free component. It's controlling everything, how the component will be nuked up, how it's born, when it's disposed, all that thing. And I'm writing the unit test. I don't have any possibilities to inject something in order to mock it or test it or whatever. So this is anti-pattern. The straightforward answer to this refactoring, just you require from the constructor. That's it. Or if you do have a local default, let's say by default, if you just knew this thing up, it will use dev now, it will not output anyway. You can go with the property injection. You just, if you want, you can override. If you don't, you just output into dev now. Another anti-pattern is called bastard injections. This particular guy, what it does, it's basically, you do have a even bastard injection service. So for instance, looking at the code here, it looks like this particular constructor was the first one for the developer who wrote it. And yeah, maybe in this particular constructor, all the logic that we saw in the previous channel service, reading up the configuration files, all the stuff, that was added by default. And now somebody came in and, I read this book, unit testing, and we should test our services, and we should be doing that. And then the developer looking at this particular constructor says that, okay, I can actually overload the constructor and leave this one as is, and then basically create another constructor which actually accepts the channel instance, or iChannel instance. In this particular case, looking at the component, it looks like it actually can't make its mind that either you're using console channel or I am supposed to supply somehow some other implementation. Actually, more obvious refactoring would be to go for the property injection because this looks like you do have a local default. It's in this case particularly, it's a console channel. So just refactor the property injection, and then it will be really obvious from an API consumer perspective that you don't have a pollution here. Which constructor should I use? The default, or should I somehow provide the channel? The next one is so-called constraint constructors. This particular pattern I've seen a lot in the code bases I've been working on. And basically, it lays down to the statement that the framework or somebody else on top of who you are writing your application actually decides how your component will be worded, or what kind of basically constructor that component will have. And the most obvious straightforward example is that some sort of framework uses activator.create instance by the given type. It just fires your component up, which means that your component has to have a default constructor with no arguments, otherwise activator will just blow up. One of the most obvious example of this one is entity framework entities itself. You can't have a dependency injection in the constructor because just entity framework will blow up. And the last one, and the most discussed, I guess, is the service locator. And service locator is, at first it looks like not so bad pattern. That basically what it means is, for instance, in this case, looking at the API, looking particularly at the constructor, I see that there is no other arguments for the constructor. So me as an API consumer, I assume, okay, I'll just fire it up and I can use it. But if you will take a look under the hood, what's happening is that actually there is pretty interesting things going on. So this particular component assumes that there is object called service collection.current, which basically holds a collection of registered types or abstractions and mapping between the abstraction and the implementation. It could be even an IOC container, which is hidden behind the service locator. So it doesn't matter actually. The key point here is that the usage of this particular service locator antipattern, not the mechanics. A lot of cases we do have like a resolve method or create method or find or whatever. Actually, the factor here is how you are using that service locator antipattern. If you are requiring dependencies seamlessly under the hood implicitly, that's the antipattern. If you are supplying the, for instance, abstract factory, which is able to create the types, and it's part of the infrastructure, but not of the application code is here, that's is a different application. It's not anymore antipattern. It's becoming as an abstract factory to create the types. Because obviously, in like modern applications, there is a scenario when you have just a type description and you have to obtain the type instance. You have to somehow create the actual instance which is doing the job. So those are not all antipatterns. There's a lot of other antipatterns. These are like most well-known antipatterns. Any question? Maybe we'll start with Luke. So for the service locator, the key factor here is that you as a framework, you don't need to ask for the service locator, service collection, iService provider, whatever. You will be told these are the dependencies, we can fire up in this way, and it's happening in a really small place in application, actually. So this is actually known as a holding principle. Thank you very much for the interview, we will call you. Don't call us. And that's never happened. Even a few years ago, there has been an attempt from Microsoft Patents and Practices Group actually to unify all the IOC containers or dependency injection containers under one common service locator, which is actually one of the authors of this package is the guy who wrote the book. And then he's like, understood, okay, that was a silly idea. So, just returning to this particular topic, abstract factory versus service locator, it's a really tiny differential between each other. This is ordinary service locator. Some sort of, either this is interface or abstract class or whatever, it doesn't matter. It has a method called resolve or create or find or whatever. You give you a T and it gives you back the T. And this is abstract factory. It looks like really similar. They give some context, blah, blah, blah. You return back T. The key difference actually is the type definition. In this particular case, it's written that this particular abstract factory can only create those particular types. In this case, service locator can create anything. Just, you ask me, I will try to create. That's the service locator. And if it's used in the application code, it becomes unprotected. In this case, type argument here. So it means that, okay, I can create person repositories only. That's it. If you ask me, I don't know, car repositories, sorry, I can't create them. I don't have information. Use another factory. So, these are the antipatterns. And of course, I've used all of them. That's okay. I've used all of them, and actually, was it a disaster? No, it wasn't. At the beginning, because I wasn't aware of a better way then. I wasn't aware that you are able actually to refactor your code in order to make it more maintainable, testable, recoverable, whatever. All right, so next question is, okay, I've seen the I patterns, I've seen the anti-patterns, what should I do, where should I start? In the book, actually, it's called improvements DI, or Dependency Injection Improvements, or basically later on the author renamed it to the pure DI. Idea is that when you need a service and it has a dependency injection through the constructors, through the properties, through the ambient context, not through everything, through the methods, whatever, you actually just move it up. You use a new keyword to fire up that particular object or that particular component. You say, okay, that component needs these dependencies, you somehow obtain the instances of those dependencies and you just build up manually. It's of course not very productive as system enrolling and constructors changes and the arguments go away, come in, so you have to always refactor that particular piece of code. Another way actually is to do it with the container. And the key factor here in dependency injection, the DI container or IOC container, as maybe also know, it's actually optional. It's not mandatory. You can have one. If you have one, it will ease your life and it will be much easier to compose the object graph. If you don't have it, that's fine. You can fire everything up manually. So there are a lot of IOC containers. Kind of key takeaway here is that you just have to know what you need. And you can go with, what is it? Do it yourself or dry IOC. It's really simple and it does nothing all. You just fires up the object graph and analyzing the constructors. So actually the key takeaway is that you just have to know your requirements and then you just pick up one of these containers. It doesn't make sense to produce your own DI container. It doesn't make sense. There's bazillions of them. Even ASP.NET Core has one as well, which is really unfortunate. So there are actually a few patterns related with the DI containers themselves. The first one is, and one of the kind of main mind-shifting pattern when it comes to the applying dependency injection is so-called the composition root. Composition root is some really tiny place in your application. Either you have a, sometimes they're referring to lasagna architecture, because it's layered as a lasagna between some spaghetti. But basically that's a really small place in the application where you compose everything that needs for that particular operation. Usually if we are referring to the web applications, that's a I controller factory. Because all the requests most probably goes to the first first surface, what's hidden is the controller. So if you're asking the controller, well, in order to execute my action, I need those dependencies. So this is the place where you actually fire up the whole object graph. Maybe that dependency requires another dependency, that another dependency requires those three dependencies. So that's the place where you actually compose the whole object graph. If it's done through the container, you just ask, okay, please resolve me this particular object or this particular controller. If you're having different architecture, the same story applies. You have a composition root somewhere. In this particular case, you have a hexagonal architecture. It could be also onion architecture. It doesn't matter. There is a place, and most preferably, it's really, really close to the entry point of the application. Really close. If you do have a console application, for some reason, let's say it's a batch job, usually they are made as a Windows service or X, whatever. It should be the first line after the main method. Just compose everything you need, and then invoke that particular controller or that particular component. For instance, in the old times when you have MVC 4 or 5, whatever, you're doing something in global assets. You're basically registering this abstraction, that implementation, and you're doing that in the iController factory. Just first request comes in, MVC gives you all the information that it's able to collect, like this is the controller type, controller name, this is the context, all that stuff, and just fire it up. And nowadays in the core, you're doing it through the startup CS and root in Google. So it's actually done automatically by you, but that's the place where it happens. In this particular case is, I think, BPF or some other application. Or depending on the framework, it may change, but it's really, really close to the entrance of the application. Another one pattern is register, resolve, release, or triple R. First of all, you register abstractions, implementations, and then you do have a resolve phase. Then you're just resolving, okay, incoming request, I have to resolve this particular controller, fire up all the dependencies, etc. Create an instance, invoke, and release the controller. Because one of the dependencies might be indisposable. We have to basically heat away, right? And give the control to the garbage collector. All right, and also regarding the containers, it's really, really important to remember about the lifetimes of the dependencies. If you mismatch them, funny things may happen. For instance, if you have a singleton dependency with the dependency that's created always when you're asking for the dependency, and if you mismatch and singleton refers to that particular dependency called transit, so it becomes singleton as well. So you have to think about the lifetimes of how to configure that. And it's you just basically read it up in the DI container documentation. They are kind of describing each lifetime, supported lifetime by that container, and applications when that particular timeline should be, lifetime should be used. All right. Regarding the personal experience on the DI, first of all, there is a so-called conforming container. And conforming container means that, for instance, in this particular open source project of mine, was so that I was asked to create an instance of the given type. So that was the case. I just was given a strategy by the type, and I just need to do it up or basically create an instance and then execute that strategy. And what we came up with is okay, we do we know that there's DI containers. Why don't we just create an interface in our framework, and then we create additional packages for each of the DI containers. So basically, they are acting as an adapter between one framework and another DI container. So if you need something, okay, you go to that package, ask for the dependency, and the dependency goes to the DI container and resolving them, which is actually conforming container. But you saw the list of the DI containers. What if my application is using one of the DI container, and this particular library or any other library doesn't have an adapter for that particular DI container? Basically, you are ending up in the dead end. So if you see that there's an inject, there's structure map 2.6, Unity, maybe some other IOC containers, so kind of most commonly used, and that's it. And if you're using different, so the refactoring for this particular case is that you actually are supplying the factory of those types, and the factory belongs to the consumer application. It's not something that's part of this application or this framework. It belongs to the consumer. That's one of the refactoring. Another refactoring is actually you are supplying an array or list or whatever of the strategies already created. How you create them, I don't care. You just give me and I will just do some black magic on those strategies. So that's the refactoring case. It of course really like an abstract level, but basically it's the refactoring way. And I couldn't be wrong. Actually, scanning through the NuGet feed, I saw a lot of those cases when you have a specific DI container adapter package for some framework. In this case, we are looking at the Nancy. You have AutoFark, you have DryOIC, you have Ninja. Somewhere down there was a structure map, this version, that version, blah, blah, blah. So this is actually not fun. You have to think through how you can avoid this one. Another one is the constructor injection. The constructor injection, actually, we can saw a sample in a default ASP core application. Can you spot over injection here? What if customer asks, well, we are pretty legacy customers, please send us notifications through the fax. That means that, well, should I add new dependency here, like iFax sender? And then another customer comes in, well, fax okay, email okay, SMS okay, well, we are really modern. We would like to involve webhook on this one. Okay, you just fire up a new dependency here and we are done, right? So actually, regarding the constructor over-injection, it means that you have to refactor to so-called factory services. In this particular case, you actually should require a notification sender. I don't care what kind of channels, physical channels you will have there with you. I will just send that notification to you, and you will handle that, either through the SMS, through the emails, through the fax, whatever, I don't care. That's one dependency. And actually, looking at the solid, it really just kicks you in the face that this particular class is going to violate the single responsibility principle. It knows too much. Because I know about email, I know about SMS, I know about how the things work. It's too much. You have to do something to that class. First, you can close eyes and continue to it. And you might end up with that together, sitting both of them at the table. Maintaining legacy. Another thing is with the role interfaces and service factory, service locator. Sometimes on the internet there are samples that, for instance, you perform some kind of method on the component, and that component goes to the service locator. Either it was injected, or it's a static access or whatever, and it asks, okay, give me I customer validator, for instance. And if you do have a registration for that interface, if you have a implementation for that abstraction, I will use it and I will validate my customer, my given customer. If you don't have that registration, I'll just skip it. The problem with this one is that it's involving the service locator. So you're just asking that service locator, do you have that implementation? If you don't, I will skip. If you have, I will involve it. So actually refactoring here could be that you always are injecting some sort of validator. If you do not have one, you're just injecting so-called a null object, which does nothing. I implement customer validator, but I do nothing. I always return true. Yes, that customer really great customer. Go. So that means that you're eliminating the service locator. You don't need to ask anybody. It will be given by you. Just asking, okay, I will perform a validation. Just give me something that can validate. Either this is a real validator, or this is a so-called null object, which does nothing. And then you are eliminating. And there's various cases and various examples how you actually can refactor the code in order to really prove that service locator is applicable if it's using an application code. Security, if you need to check, if you don't need the answer, if you just, for instance, throws an exception if you try to misuse the functionality, that actually should be implemented through the interceptor. Because somebody else is controlling that particular method invocation. If you don't pass security, you just can't invoke it. I can show you later on. The next one actually is really interesting. There are sometimes that just the language structure that you can't use injection. Just can't. That's the way how the language is working. In this case, we can return to our great ASP or web application. For instance, we do have attribute. Some underscore attribute handles authentication, authorization, whatever. This particular attribute requires, okay, in order for me to execute my logic, I need this dependency, I need the iSample service, whatever. Okay, very good. We have a user secure attribute, and we would like to apply this guy to the home controller. What do? We go to home controller and type user secure attribute, and then ask, okay, in order to create myself, I will show you. So it requires iSample service as a constructor injection, because that's a dependency. It should demand dependency. As you know, in the .NET, for the attributes, there is no way to inject this. You can inject some integers, maybe some strings, something, which is compile time variant or values. You can't inject iSample service, which means that it becomes kind of useless, right? So the question is, how? Microsoft came up with this really brilliant idea. So you, instead of attributing directly with the secure attribute, we can ask service filter, and then you can give a type of the secure attribute. What it will give you is that the service filter actually has parameterless constructor, and by the given type, it will just go through the dependency injection, DI container, whatever, in order to create an instance of this Uber secure attribute. In this case, this is valid. This is working. I tested it. So, can you spot the problem here? I can give you a multi-way.
You will not see it as an attribute in a reflection.
Huh?
You will not see that as an attribute. Like Uber secure attribute will be not listed in your reflection.
It is an attribute.
Yeah, but how it's applied to the actual class? I mean, via reflection, how do you see if you get type of home controller?
You will. MEC will give you controller descriptor context something, and then you can request, okay, this particular controller has this attribute, and if it does, then you can do some logic. You can get access to this one information. Yes. Either you apply to the action or the controller level of this method. You have that information.
Problem is because you are introducing new dependency.
You mean this service filter? I need to apply that because that contains my logic. I need to apply to this constructor. No. Okay. Next question. I can actually do like this. And it compiles.
There is no restriction flag.
There is a restriction, but only during the runtime. So the problem is that it compiles everything. Everything is green. My tests are green, and I just commit, push, and go home. And then see, and the nightly build is just broken because of the small test fell. Why? Because MEC blew up. So the problem here is that it actually, if we look at the constructor of this guy, and I can try to zoom in there, it requires type, any kind of type. Just give me something, I don't care. And then during the runtime, okay, I will try to create an instance. I will expect that this particular type is part of iFilter metadata or some kind of interface. If it's not, I'm just.
Yes, but if iServices dependency is not registered, it will compile anyway.
Yes, that's correct. Wanna go? Let's go. Yes, actually, if you will misconfigure the container, it will anyway blow up. But the resolution here is that you can't understand, in this particular case, you don't have information on the compiler type, compile type, because you can give anything. It's of course not logical in this particular case to give a controller as a filter, but instead if you misconfigured the container, that's basically your fault of composition root, but not the compiler. It's kind of really similar. Yes, I agree. Good. So, one extra bonus with dependency injection. For instance, let's say we have, again, this cool chat service. And let's say, looking at the logs of the chat service, the service owners, chat owners began with the solution, we have to set some censoring around the messaging because somebody is basically really shouting out. And we need to just replace those ones because log files are written by children, for instance. So the question is, let's say that in this particular case we have the chat channel, and the chat channel, if you take a look at the dependency, on the chat service, it actually requires the iMessage formatter. So this is some guy that just formats the message, because it depends on where exactly you would like to add this dependency. But let's say this is done in the message formatter. So the message formatter itself is a pretty straightforward. It just passes through the message, does nothing. But in this case, you have to replace the bad words with, for instance, 5 asterisks. Normally, what would you do is probably, I would even maybe do it, just go into this particular message and inspect the message. Put in particular method and inspect the given message. If that message contains those bad words, that's pretty naive implementation, but still, you're just replacing with something. Using the dependency injection, in this particular case, I'm just building up the container and registering all the abstractions against the implementations. And one of the cool feature about the dependency injection is that actually I can do similar thing. I can ask decorate with, and this is a formatter. I can say here sensor formatter intersector, and I give this formatter. So what I did is actually tell that I'm not touching the original class. The original class remains the same. We just want to put message to the whatever channel you are basically formatting the message. And again, this goes closely to open-close principle. I'm not modifying the original class. I'm actually adding the behavior on top of that. Because basically solid is about appending, not changing any sort of way. So you actually, in this case, when somebody asks for iMessage formatter, it basically gives a sensor message interceptor, which under the hood received either formatter and then just implements the same interface as iMessage formatter. And if somebody asks to format the message, it just looks for bad words and replaces them, and then delegates call further to the actual iMessage formatter. So it means the message already has been reformatted and then output. So I'm not touching the original class, I'm just adding on top of the existing ones, decorating, intercepting, so there's various cases. And the similar case could be implemented in the logging, caching, authorization, authentication, all those things. And decorating, I'm not touching. Of course, there is a cases when you need to change the original class, but that's a different case. So, with the dependency injection, we can create loosely coupled code. We actually have to demand dependencies, either through basically three patterns, or if you need answer, you go with the ambient context. If it's cross-cutting and so on. You actually have to know your DI container if you're using one, because there are really brilliant features inside those containers. You have to look for the answer patterns, and if of course time and economy and all that stuff allows you, you try to refactor the code in order to create a more maintainable code. And you actually have to be a voice couple. So you leave the code base better as you write. Otherwise we all may end up with this guy together. Alright. Thank you very much. Any questions so far?
I have a question.
Yeah.
What about the you told about example about this attribute and type of. Can we solve this problem using the C# compiler and maybe write our own rules that that type, and if the type is not the one we expect, maybe we will underline or maybe something like that. That's why we could solve this.
Yes, you can. I would actually try to solve it a bit different. I would try to actually not add logic to the attribute itself. Because attributes has to be passive attributes. It's a metadata. It doesn't contain logic. It's a metadata. Because you're annotating that particular controller, action, whatever, because that's some sort of special. And the logic actually is inside the filter. So adding a specific filter in the pipeline, when the request goes through, you will get the control of inspecting the context, do some stuff, and you just inspect, okay, does this container, or does this controller have this attribute? If it does, I'm doing my logic. If it doesn't, I'm just doing nothing. And that's the way how you can plug in, plug out that filter. You don't need to remove the attributes or whatever. You just can replace, even if you have the attribute on the code still, you can just unplug the filter, and the attribute becomes obsolete. So you don't have to revisit all the code base to remove that attribute. So, and that also gives you a possibility to reuse the business logic anywhere else. If that's an attribute and it's inside the attribute, you have to come up with some brilliant idea how to execute that attribute logic, for instance, in a console application, if you need one. So otherwise, I would assume that the attribute is a metadata. It doesn't contain any detail. It shouldn't. It's called a passive attribute. That's a guy very special.